Okay, today we'll be talking about chapter 14.3, which is the change of variables in polar coordinates. So the reason why we do that is because some integrals are hard to do in rectangular, so we switch to polar coordinates in order to make an easy integral. As we know from Calc 2, x equals r cosine theta, and y equals r sine theta. Okay, so with that information, we can also get the tangent, which is y over x. So we'll do an example here of an integral. We'll convert it from rectangular into polar. So let's evaluate it. Let R be an annular region lying between the circles so we have two circles here. We know one of them has radius of 1 and the other one has radius of rad 5. So let's draw out the picture first. We know the first one is radius 1 and rad 5 is somewhere right here. So we draw an outer circle. So we'll get the region R, which is also the radius between the outside of the circle and inside of this circle. So we have this. Alright, so now from this graph we can see that our R is in between rad 5 and 1, and we know that our theta, since it's a circle, it goes from 0 to 2 pi. So now that we know that, we'll set up the integral. First one goes from 0 to 2 pi. Second one from 1 to rad 5. We know what x, we know that this is r cosine theta, as we mentioned in the beginning, but we square it, and we also know what y is. So inside the integral, you will get an r cosine of theta, and you have to add it to r sine of theta. Don't forget your r, your extra r, and your dr d theta. So a lot of people forget this r, which messes up the entire problem. So make sure you don't forget that. So now to evaluate, we'll use this. So be patient with me, guys. This is a pretty long integral. But you'll see the benefits of converting it from rectangular to polar. So this is the first one. we have to integrate from 1 to rad 5. Okay, that's for dr, so we still have d theta, don't forget that, guys. After that, we simplified it even further. This becomes 6 cosine squared theta plus 5 rad 5 minus 1 3 sine theta d theta. And finally, we can go one more step to simplifying this, making this 3 plus 3 cosine 2 theta plus the 5 that you had, rad 5, 3 minus 1 sine theta d theta. We're almost done. We'll do integrate it one more time with respect to theta. So this 3 just gets the theta. This 3 cosine 2 theta becomes 3 sine 2 theta over 2. Don't forget that 2. And this one is 5 root 5 minus 1 over 3. Since it was a sine, it converts it to a cosine. It's a negative 2, don't forget. Theta, and we integrate this whole thing from 0 to 2 pi. And our final answer after simplification is 6 pi. As you can see, it's a very long integral, but it's 3 times shorter than it would be if you didn't change to polar coordinates. Imagine trying to figure what it was in rectangular coordinates. Another thing we can do is find the surface with polar coordinates. So we'll use, for this example 2, we will use polar coordinates, what we just learned, to find volume now. Of a solid region. So make sure to remember that it has to be bounded by something else. So bounded above by the hemisphere. So as you can see, hemisphere, it's something that would be like a circle. Anything that has to do with polar. So we have z equals square root of 16 minus x squared minus y squared. So that is in rectangular. So we know x squared plus y squared is less than or equal to 4. So x has to be between 4 minus y squared and negative rad 4 minus y squared. And then z is from the original function and 0. Okay. Our r is just from 0 to 2. So now we know the height and we know volume equals the region from the double integral x, y, dA. So since we converted everything, we'll just plug it all in. 2 pi since it's polar, and we found the regions already. 0 to 2, and we're doing 16 minus r squared. And again, don't forget this r, then your dr, d theta, As you can see, it simplified the whole entire question. So when we solve this integral, which is easier than doing this, from -2 to 2, again, this is still a possible way to do it, but polar just makes everything easier. Compare these two integrals, and you decide which one's easier. As you can see, polar will always be the easier one to solve. This is why we convert to polar. Thank you.